So we looked at the idea of saying, for example, let's move here, 30 degrees on a sine function, and how the hypotenuse is about twice as big as the opposite of 30 degrees, and you could read off that the 0.5 or its opposite divided by hypotenuse is 0.5 divided by 1 would give you an output value of 1, because the y of this function is opposite divide by hypotenuse there. And so what we realize then is, for the question that I've been discussing, 0.799, its value of 0.799 is around here and is about 53 degrees. That is the output value. And one other way to visualize that is to recognize that from the center point of our circular S structure to there, we have a certain hypotenuse length. The opposite is now this blue line, and the angle in here would be 53 degrees. So that is the right angle triangle that is being produced, if I was to give it that angle of 53 degrees. But what is more important is that you can also consider that the same triangle will manifest itself at this position here. So in these circumstances, we can see very quickly that I can produce the same structure like that. And in so doing, you can see that if I type in the equivalent angle for this position into my sine function, I should still get 0.799. Moreover, if I consider also that this can move out to here, then also the triangles that fit into this one will manifest the same outcome. They are the same angle of 53 degrees, but they do not say 53 degrees. So that's one thing to recognize. I'm just going to finish this off so we can have that conversation about the correct angle that is actually in there and the correct angles involved. So yes, this is 53 degrees and this is 53 degrees. So is this 53 degrees, but we cannot say that on the x-axis the output value is 53 degrees. Why? Well, here is one of the reasons as to why. What I did is I could say, for example, 30 degrees, if I was to take the other section within the circle that right angles triangles can manifest for a sine function. So if I go to here and I say to you, right, this circumstance, let's say, let's stick with blue. So this is my opposite and this is my hypotenuse. This is also 30 degrees, but it is not 30 degrees round the circle. That is not actually what is the case. It might be the right angle triangle, which is why it produces the same opposite and hypotenuse ratio, but instead this angle is 180 degrees, take away 30, this 30 in here. This here is 30 degrees round here, there. That's very unaesthetically pleasing. This is not aesthetically pleasing at all. I didn't even know what word I just used to describe it. That's how bad it looked. The idea is that we'd have to suggest that this is 150 degrees because it's 180 take away 30. So what we'd do is we'd say at this point, we know that sine 30 will produce the same output value as sine 150 degrees. So therefore, when we are looking at, we can clean this up now. When we are looking at a circumstance of 0.7, let's try and sketch this on. Let's say that is the height of 0.7 there. So there is our 0.7. I might be able to make it slightly more accurate to aid in our understanding and not cause any further misconceptions. There is our 0.7 in height. This is a height of 1 as depicted by there. It's a radius of a circle, so it must be the same height. There is the opposite of our triangle. I'm going to use the same color to produce the adjacent of our triangle. This circumstance in here, we can, let's get rid of that 30. It's getting on my, oh, no, that messes things up a little bit too much. That's the wrong one that I want anyway. In fact, no, we'll keep 30 anyway so that we can keep it relative. There, what I'm going to do instead is give you 53 degrees for this triangle. So that triangle, 1, and then 2, and then finally 3 that is 53 degrees relative to 30 degrees. Now, the idea is that, of course, then, as depicted here, 53 degrees manifests itself in the same type of triangle at this point. So I could do the same thing here and say that finally then this should also be 53 degrees in here. So I can just write that in. So let's talk about negative, because that's where this question truly comes alive. So that's also 53 degrees. What does it mean to go negative? Well, what it means to go negative is simply, we'll keep this one, is simply to go minus. So minus 30 would manifest here, for example, minus 45, minus 90. This, therefore, if this is minus 180, would be here, minus 270, if I just go in this direction from this point. And that's what's happening. Minus 90, the bottom part of our circle, minus 90. So this position here is minus 90 there, and so is this position here, minus 90. Minus 180 degrees there is minus 180 degrees. And notice, as we drew before, I said to you that the same triangle will manifest here. Well, what's that? Well, there's minus 90, minus 180, minus 270. It seems that it's within this range from minus 180 to 270, and it is particularly these two triangles here, this one and this one, as I've drawn there and there. So that's what we mean by minus. We're going backwards round the circle to come across these two same triangles again, but for different angles. It is 53 degrees in here and here. But we're not going to mention that. Notice that this point at the top is minus 270 if I went walking backwards, and that's why the minus 270 appears in here. To conclude what I've stated therefore that this can be seen on our original graph as so there, between there, and then there's another one. Not considering this one, let's just say that the range of this function, the output values of this function here, are between, let's say, 180 degrees, or let's do 90 degrees and minus 270 degrees. Then the two angles that are represented in this diagram, and you could continue on forever. There's this one, of course, there's this one, there will be another one around here, there will be another one synonymously there, and it will carry on in this pattern because you can just keep going round this circle over and over again in either direction. But for these two, what I would suggest to show you how the calculations work out is we said that it's around 53 degrees for this, and it is therefore 180 degrees plus that same 53 degrees, because this is even on both sides, as you can see from this circle, they're equivalent on both sides. It's not exactly a circle, of course, circular-like in structure. So I want 180 degrees plus 53 degrees, but I also need to remember that it's minus. So around minus 233 degrees will be what we're comfortable with, and you can see that seems to be relatively good there. So that is to say that this point here that we have when we got there, what we were actually playing around with, although this is 53 degrees in terms of a right angle triangle, that's this right angle triangle there. So 1, 2, 3 sides, that angle in here is 53 degrees. Although that is the case, another way to view it is if you were to instead start here, walk your way around, and then by the time you get to this point, then actually what it is 180 plus 53 degrees. So the angle that would come out from this would be instead 2 minus 233, which is why this is a more accurate answer given the domain dependent on your exam question or problem that you wish to solve. Domain and/or range depending on which way you want to view this function. So the output values of this function, if I've suggested to you, I'm only going to do between 90 and minus 270, so I only need to write these two, but you can carry on as much as you wish.